Hi everyone, welcome. After that second video, I am going for third video, and I am going to go with the further syllabus continuation. That is effect of pressure. That is PB and PC. PB means what? Boiler pressure. PC means condenser pressure. So after that, also we want to see the effect of temperature in the Rankine cycle. What is effect means? If I increase boiler pressure, whether efficiency of Rankine cycle increases or decreases. If I increase condenser pressure, whether it increases or decreases. Temperature also same case. In the if I increase turbine input temperature, whether it is increasing the work done or not. If I increase boiler input water temperature, that is feed water temperature, if I increase, whether it is going to what is the efficiency changes, that we are going to see here. Before seeing that, we know the efficiency. Already we have done this method in the last class also. Last means previous classroom classes. Efficiency is net work output divided by heat supplied. I can write like this also in terms of heat supplied and heat rejected is Hs minus Hr divided by Hs. 1 minus Hr by Hs. So if I see the analysis, if I decrease Hr, efficiency is going to increase. If I increase Hs, efficiency is also going to increase. I have said some small method to check. You check in that way only, so that you will understand the things. Now, if I am telling Hs and Hr, these are all heat rejected and heat supplied. That holds good for Ts diagram, right? So, in the Ts or Hs diagram, what you need to check is Hr is decreasing or not, or Hs is increasing or not. If both are happening and if this is less and this is more, then efficiency is again efficiency is going to increase, right? So first one we will see effect of condenser pressure. So condenser pressure is which? P2 and P3 are condenser pressures, right? So condenser is what? Again converting steam to wet, steam to liquid. But here we have one limitation. We cannot reduce the condenser pressure below a certain limit so that water converts into ice or something. So we have certain limit of condenser temperature, right? So below that we cannot go for that temperature to increase the efficiency and other things. Again it becomes a waste and it's not practical again, right? So here this case becomes PB and PC. PC actually is 1, 2, 3, 4, 5 is actual Rankine cycle. I will just decrease its condenser pressure. I am decreasing condenser pressure to 2 dash and 3 dash. So this line shifts like this and 4 dash. Right. Same thing I will see here. Right. So actual heat, that is work done, is this closed cycle now. Closed envelope is 1, 2, 3, 4, 5, 1. And actual, that is heat supplied. This is actual. But this is increased this much due to this condenser pressure. What I am saying, you listen again. This heat supplied is increasing up to this area. This area means heat supplied is increasing here. Right. What about heat rejection? Earlier heat rejection was this much. Heat rejection was this much earlier. Now this is increased up to this part is increased. This part is extra, this part is heat rejection is increased. Earlier it was this much. Now extra part is increased this much, but heat supplied is more as compared to increase in the heat rejection. So heat rejection is again here little bit, this as compared to this is less only. So again efficiency is going to increase here. So please analyze. TS diagram or HS diagram will give you heat supplied and heat rejection. So in the TS diagram, if I have one curve like this, TS diagram, if I have one rectangle, what is, if someone asks heat supplied, this area itself is heat supplied. What is heat rejected? Area below the heat rejected, whatever area is heat rejected, and this is heat supplied. Here also this is heat supplied, and if I, due to decrease in the condenser pressure, this much heat supplied is increasing. That is what I have written. Heat supplied is increasing. Heat rejection is also increasing, but only slight heat rejection is increasing. As compared to heat supplied, it is again less, so efficiency is going to increase. Next, I hope this is clear. Again, you read in the notes whatever I have given. In clearly, I have given the points. Effect of boiler pressure. Same thing. Whatever here we have decreased the condenser pressure because condenser work is to decrease the temperature. What is the work of boiler? To increase the temperature. Now I will increase the boiler temperature from 4 to 4 dash. That is, inlet temperature of turbine is 1, actually it is 1, I have increased to 1 dash, means temperature is increased. Here also you just check it, actual heat supplied was this is increased this much, this is increased this much, total this much is heat increased, this much extra, this much is heat rejection. Here also heat supplied is increased, heat rejection is, as compared to this it is reduced, efficiency is going to increase. So here also you can see increase in the heat supply, and there is increase in the heat rejection also. Heat rejection also there is increase. This much increase is the heat rejection, but the thing is it is very less, so efficiency is going to increase, right? Next, effect of these two are over, PP and PC. So if I, what is the conclusion I will tell you once again, if I increase the boiler pressure, efficiency is going to increase. If I decrease the condenser pressure, efficiency is going to increase. So here decrease is required, here increase is required, but both are having limitations. Up to certain limit only you can decrease, up to certain limit only you can increase. So this is what is the thing. So here we have effect of temperature again. So that is what I have explained already, superheating. If I actually at point 1 it is a dry steam, if I increase its temperature it increases the superheating. So extra heat supplied, actually this much is heat supplied, increase this much, and this much is extra heat rejection, but heat rejection in extra is very less, heat supplied extra is more, so heat supplied is increased here, so efficiency is again going to increase here. One more temperature effect is feed water temperature. Feed water temperature, how you can do? We have to use economizer, we have to use reheater, we have to use some other method, preheating of water after the pump. If you heat that water and supply in the boiler, fuel consumption will be slightly reduced and there is increase in the efficiency. So that is what is effect of pressure and temperature in the Rankine cycle. This is very important from the exam point of view. Many times he has asked in the video question papers. Right. So next one more point I will go for. So whatever we have studied, these are all theoretical cycles. Theoretically, we have how we have studied in gas power cycles, actual gas power and theoretical gas power, ideal gas power and actual gas power. Like that here also, this whatever we have studied, this is ideal Rankine cycle. Ideal Rankine cycle is also having some isothermal process and other things. I will just explain here. Actual Vapour cycle. What is actual Vapour? I will draw the this one, which is that superheat cycle only I will do. Right. So I just name this according to this one: 1, 2, 3, 4, 5, and 6. See, these things, whatever I am saying here, what we have studied already, turbine and pump both are working with is isentropic process, but practically not possible, right? So this is already we have seen. So actually this is actual Rankine, this is ideal Rankine cycle. Practically this line, ideally it will be very straight line, but practically it does not carry like this. It will have slight curve over here, like this. So this becomes 2 dash, and here also this becomes like this, 4 dash. So arrows are like this, right? So I just read out the things. It is impossible to design pumps and turbines operating under isentropic conditions. That is practically not possible. I have written already. Because the portion of work developed is utilized for overcoming friction between working fluid and walls and between molecules of fluid itself. Heat losses from the steam to surroundings are happening, so isentropic is not holding good here. So in actual case, we have, if you want to see the efficiency, actual efficiency of turbine and pump are given by actual efficiency of turbine and pump are given by efficiency of turbine is equal to actual turbine work divided by isentropic turbine work. That is, actual turbine work is what? H1 minus H2 dash. This dotted is actual. Ideal is H1 minus H2. Similarly, if I write for the pump, actual pump isentropic pump work, because that is less, isentropic pump work divided by actual pump work, that is isentropic is H4 minus H3, here H4 dash minus H3. So this is the actual Vapour cycle. So here there are two isentropic processes, so that we have converted into actual case, and in the further while solving the problem we solve the actual problems. So while solving that, you will become again more and more clear. So today whatever we have discussed, that is till now, again once again I will just have a glance. We have studied steam power plant, second Rankine Carnot cycle and efficiency, drawbacks, a simple Rankine cycle, and Rankine cycle with superheat. Then we have seen this one, comparison, and here also efficiency, comparison, then effect of PB, PC and temperature on efficiency of Rankine cycle. So and also we have seen actual Rankine cycle. So we are left with some more theory part. I will cover in further two videos. That is, again we will go for ideal regenerative Rankine cycle, and we will go for actual regenerative, and feed water heaters, and reheat cycle, and a binary cycle. This will be covering our theory part. Some two videos or three videos I will cover it. Some of the things very important from the exam point of view is comparison is very important, and this is very important. Many a times he has asked these two in the exam in this section, right? So other things are okay. Here also this is also drawback is also certainly important. So this today I will post you two videos, and tomorrow again I will continue with the further portions. Thank you very much. Thank you.